Hi and welcome to the fascinating world of blockchain. In this video, we're going to have a comprehensive session about what blockchain is and what are the different mechanisms and architectures that are used on the technology of blockchain. So, blockchain is a digital ledger technology that allows for secure, transparent, and immutable recording of transactions. It was originally developed to support Bitcoin, the first decentralized digital currency, but has since been adopted for a wide range of applications. The basic idea behind blockchain is to create a decentralized database that is maintained by a network of computers rather than a central authority. Each computer on the network or node has a copy of the database and validates new transactions before they are added to the ledger. Once a transaction is added, it cannot be altered or deleted, creating a permanent record that is transparent and secure. There are several different kinds of blockchain, each with its own unique architecture and use cases. Here are a few of the most common types. The first one is the public blockchain, and this type of blockchain is completely open and accessible to anyone who wants to participate. Bitcoin is an example of a public blockchain because it is completely decentralized and there is no need for a central authority to validate transactions, and everyone can participate in the network. Next up, we will have the private blockchain. Private blockchains are controlled by a single organization or a group of organizations. Access to the blockchain is restricted and participants must be authorized to join the network. Private blockchains are often used for business applications such as supply chain management, where transparency and security are important, but complete openness is not necessary. We also have the hybrid blockchain, which is something in between, and this kind of blockchain combines elements of both public and private blockchains. It allows for some degree of openness, but also provides more control over who can participate and validate the transactions. In addition to these types of blockchain, there are also different architectural models that can be used to implement blockchain technology. Here are a few examples. At first, we have the proof of work. In this model, participants on the network compete to solve complex mathematical puzzles in order to validate new transactions and add them to the ledger. The first node to solve the puzzle is rewarded with cryptocurrency. The next one is the proof of stake, which is also known as POS. And in a proof of stake system, participants are chosen to validate new transactions based on the amount of cryptocurrency they hold. This reduces the need for computing power, energy consumption, and making it a more sustainable option. We also have the directed acyclic graph, which is also known as DAG. DAG is an alternative to the traditional blockchain architecture. Instead of a linear chain of blocks, DAG uses a graph structure to allow for parallel processing of transactions. This can increase the scalability and transaction throughput. We also have sidechains. Sidechains are separate blockchains that are connected to the main blockchain. They allow the new features and applications to be developed without affecting the main network. So in conclusion, blockchain technology is a powerful tool for creating secure, transparent, decentralized systems. By understanding the different types of blockchain and their architectural models, you can begin to explore the potential applications and benefits of this innovative technology. Now let's talk a little bit about Bitcoin. Bitcoin is a decentralized digital currency that was first introduced in 2008 by an unknown person or group using the pseudonym Satoshi Nakamoto. The Bitcoin protocol is a set of rules that govern the behavior of the Bitcoin network. It is an open source software that allows anyone to participate in the network, and it is designed to be resistant to censorship, fraud, and corruption. Let's talk a little bit about the mechanism of Bitcoin. The Bitcoin protocol is based on a distributed ledger technology called the blockchain. The blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. About the Bitcoin architecture, the Bitcoin network is made up of set of nodes, which are computers that run the Bitcoin software and participate in the network. Nodes can be full nodes, which store a complete copy of the blockchain, or light nodes, which only store a subset of the blockchain. Transactions are broadcasted to the network, and nodes validate them and add them to the blockchain. Miners, who are nodes that perform the resource-intensive process of adding new blocks to the blockchain, are incentivized with newly created bitcoins and transaction fees. About the Bitcoin algorithm, the Bitcoin protocol uses a consensus algorithm called proof of work to validate transactions and add new blocks to the blockchain. Proof of work involves solving a computationally complex mathematical puzzle called a hash function, which requires a large amount of computing power, and this process is called mining. The first miner to solve the puzzle and add a new block to the blockchain is rewarded with newly created bitcoins and transaction fees. And about the Bitcoin transaction, it involves the transfer of ownership of bitcoins from one user to another. Each transaction is digitally signed using a private key, which is only known to the owner of the bitcoins. Transactions are broadcasted to the network and validated by nodes. Once a transaction is validated, it is added to the pool of unconfirmed transactions, which are waiting to be added to a new block. Miners select transactions from the pool and add them to a new block, which is added to the blockchain once it is validated by the network. So you might wonder how Bitcoin is secured. The security of the Bitcoin protocol is based on the use of cryptographic algorithms. Transactions are digitally signed using public key cryptography, which ensures that only the owner of the bitcoins can transfer them. The blockchain is secured using cryptographic hash functions, which make it virtually impossible to alter the contents of a block once it has been added to the blockchain. Now let's talk about the different sections of a blockchain in more details. First of all, we're going to talk about the blocks. In a blockchain system, a block is a container that holds a collection of transactions. Each block typically includes a block header and a list of transactions. The block header contains metadata such as a reference to the previous block, a timestamp, a nonce, and other relevant information. The transactions between a block represent the data being recorded on the blockchain, such as financial transactions or smart contract interactions. On the other hand, we have the nodes. Nodes are the individual participants in a blockchain network. They maintain copies of the entire blockchain ledger and play crucial roles in maintaining the network's integrity. There are different types of nodes, including the full nodes, mining nodes, and lightweight nodes. Full nodes store and validate all transactions and blocks, while mining nodes additionally participate in the mining process to add new blocks to the blockchain. Lightweight nodes, also known as SPV or Simplified Payment Verification nodes, store a subset of the blockchain and rely on full nodes for verification. Next up, let's talk about nonce. A nonce, short form for number used once, is a random or incremental value used in the mining process of proof-of-work algorithms. Miners modify the nonce value in the block header to find a suitable hash that satisfies the network's difficulty requirement. By repeatedly changing the nonce and calculating the hash, miners engage in a computationally intensive process to search for a valid block hash. The nonce is adjustable to provide a large search space and make the mining process challenging, requiring significant computational effort. And in the end, we have the hashes. A hash function is a mathematical algorithm that takes an input and produces a fixed length string of characters, which is the hash output. In the context of blockchain cryptography, hash functions such as SHA-256 or Secure Hash Algorithm 256 bits are commonly used. Hash functions have several important properties. The first property is deterministic. The same input will always produce the same output hash. The second property is one-way. It is computationally infeasible to reverse engineer the original input from the hash output. And the third property is collision resistance. It is highly improbable for two different inputs to produce the same hash output. And in the end, we have the avalanche effect. A small change in the input will result in significantly different hash output. In the mining process, miners modify the nonce value and combine it with the block header data. They repeatedly hash the resulting data until a hash is found that meets the network's difficulty requirements. This involves finding a hash that has a certain number of leading zeros in the case of proof of work. The nonce value is adjusted to change the input data, generating a new hash until a valid hash that satisfies the difficulty condition is discovered. The winning miner's valid hash is added to the blockchain as a proof of work, signifying the successful mining of a block. In summary, blocks contain collections of transactions. Nodes maintain copies of the blockchain. The nonce is an adjustable value used in the mining process to find a valid hash, and hashes are unique digital fingerprints generated by applying hash functions to block data. Together, these components contribute to the secure and decentralized nature of a blockchain system. That's it for this part of our tutorial, and in the next one we'll talk about the Ethereum blockchain, smart contracts, and decentralized applications.